Team Talk 15 is back again.
On the road.
What's going on?
Let's see what topics we have for you today.
Yeah.
One part in the front plate is the so-called filter holder. And most other cameras have that filter, which probably every image sensor-based camera requires. A UV infrared cutoff filter already glued to the image sensor itself, for example. And the problem, or the general reason for that, is that our human vision, our eyes, see wavelengths from around 318 nanometers to 714 nanometers, where the lower end reflects to ultraviolet, or then blue as the visible spectrum, and the top end around 700 nanometers, the red or then infrared spectrum. The problem is that image sensors, like the CMOSIS CMV12000 we're using, has a little bit of sensitivity in the ultraviolet spectrum and quite a large sensitivity in the infrared spectrum. So the image sensor or the camera actually sees more colors or a wider spectrum as we humans do. The problem is that if you look at the response curve, the infrared doesn't affect just the red photosites, but it affects pretty much all the colors. So it kind of pollutes the image, so to say. It's infrared pollution. And a small part of the ultraviolet also, a pollution in the blue. So the reason for this infrared cutoff, UV cutoff filter, is to reduce the amount of light already entering the image sensor. You kind of block the light from entering. It's a reflective filter, and you reflect the bad wavelengths away from the image sensor. Now, currently, like in the DEF kit, we ship an infrared UV cutoff filter as a screw-on filter for the lens. So you just add it at the end of the lens. But in the Optima setup, this filter is already between the lens and the image sensor, mounted directly inside the camera enclosure, basically. Again, it's replaceable, it's removable if you want.
If you want to shoot infrared photography.
Exactly, then it's of course handy to have that option. But for most cases where you need natural colors, you want the UV infrared light filter installed already inside the camera underneath the lens mount, like the E-mount here.
Also, you can have other filters there, like
exactly.
Anti-aliasing filter, anything.
Anything. You can also add a filter that only lets infrared pass, for example, if you want to do real infrared photography or so on. And so we got in touch with several companies that produce UV infrared filters so that we can integrate them already into the enclosure. And there was a wide range of suppliers.
You have done a lot of testing.
Europe, then from China, the likely cheaper ones. And we wanted to use all of them and see how they actually behave or what the difference is in the end. We indeed ordered quite a few of those samples. We get some of these beautifully packaged love the smell of image filters in the morning. So if you look at them from the side, you see that they have a light greenish bluish tint, or if you hold it the other way, a light pinkish reddish tint. And that's exactly the light being reflected by the filter and not going through, so you see it, the visible part at least. So we all approached the companies in the same way. We said we want a filter that filters out the visible color spectrum, basically, so from around 400 nanometers to around 700 nanometers. That's the passing wavelength, and everything else should stay outside, right?
So how did that go?
How did that go? Well, we received several samples from different companies with a wide difference in pricing. And then we ran all of them through the spectrometer at the university and looked at what actual wavelengths are passing and what not. And to our big surprise was that the rather expensive European providers were far from what they claimed the response curve would be. and that some of the Chinese, rather cheap products performed much better and were actually matching the response curve they said their Fantas would have with what they actually ended up having.
Yeah.
But not all of them were perfect, some better than the others. So the test results showed that there's quite a wide range of different responses. And we still haven't decided which one we will actually integrate into the filter. But it looks like it definitely makes sense to closely evaluate the results and the products we received. And another part that we discussed after these prototypes were manufactured is that we also want to incorporate an optical low-pass filter in the system in some way, or at least provide a possibility to do so. If you look at the image sensor, not every pixel or every photosite, as it's called, an image sensor has every color.
Yeah.
In the so-called Bayer pattern, which is the most widely established method of splitting up colors, you have green, red, blue, and the second green pixel, so to say, in a grid array. And what if a very fine red detail, which happens to be just 1 pixel wide basically, hits not the red pixel, but the blue one? It would be invisible, so to say. So fine structures kind of go beyond the capabilities that the image sensor can optically reproduce. And this results in the typical moire patterns with fine T-shirts or with fine structures. And so you add an optical low-pass filter, which splits up one beam of light, so to say, into a wider range, so it hits at least 4 pixels on the image sensor. So a red detail would go on the red pixel as well. This means you lose a bit of sharpness, so you sacrifice a bit of the image resolution, but in turn you regain the ability to film any structure. Moire is gone basically then.
Sure, makes sense, yeah.
And how do we integrate an optical low-pass filter if we have already occupied the filter holder with a UV infrared cutoff filter? And what we came up with is, instead of combining the 2 filters, which takes away a bit of the flexibility, because you can't do one or the other then, and we want to have 2 layers of filter holders in the lens mount, basically. So if you use just an UV infrared cutoff filter, the second holder would currently be empty, as a kind of placeholder, but would already provide the space, because the big problem is when adding things between lens and image sensor is that every glass element changes the flange focal distance, which affects the focus plane of the lens, basically. So you wouldn't focus on the exact mark on the lens anymore if there's a glass element that the distance wouldn't account for.
Yeah. So if you add too many, you couldn't focus anymore.
Exactly. So the filter holder thickness is perfectly matched to the thickness and density of the glass that it holds.
Okay.
That way, if you swap the filter holder for a different one, the different thickness will automatically compensate for that flange focal distance change.
Okay, makes sense.
Yeah. So we will design the whole stack between image sensor and lens mount to always accommodate 2 filter holders, like a UV filter, infrared cutoff filter, or in addition an optical low-pass filter, or any other filter that you want, an ND filter or artistic filter that kind of creates special light rays effects or so on. Yeah, but that's the new thing that's currently not integrated. It's a 1 filter holder design currently. Will be extended to a 2 filter holder design. Cool. And we evaluated the different filters from different suppliers and made sample footage or sample images of me holding the color checker and the name of the filter supplier. And what we witnessed so far is that pretty much all the filters work. So the colors, the natural representation of my skin, and the color checker works with all of them, no matter if they have the cutoff of the infrared a bit lower or a bit higher. So we still need to figure out, and that's maybe also something where you can help us, how much accuracy do we actually need with exactly cutting out off at 700 nanometers, or is it no big deal if it's 740 or slightly below 700? So you lose a bit of the reddish tint, bit less infrared. But does it affect the colors? Does it affect the skin tones? Does it affect the image the camera produces? That's what we're currently figuring out. And yeah, we will link to the results that we captured, different images in the description of the video and the area around the Team Talk video, so you can check it out yourself as well.
Yeah, and if you look at the picture without the infrared filter, and you might think you can just color grade that out, you really can't, because we noticed that there are even spikes in other areas of the
Yes. For example,
picture.
if you look at the plants in the background of the picture, you see that plants reflect a lot of infrared spectrum.
That's why all these infrared pictures, infrared photography pictures, they look crazy when they shoot trees.
Exactly.
They're just white.
And that's something you can't just remove. It's the same color as all the rest in the skin tones. So it's just polluted, so to say, infrared pollution. It's real.
It's real. It's real. Wake up. It's real.
Stop the pollution. Excellent.
Kill the sun.
So we talked about Axiom Micro, and the two bright minds behind the Axiom Micro are also the driving force between the new Axiom firmware. What is the firmware, you might ask? The firmware is basically the operating system inside the camera. So everything that's already there when you start using it, basically. Not the user side, configuration files, scripts, but the groundwork.
Yeah.
And so far, this firmware was hand-assembled and kind of maintained, but difficult because there was no central repository. It was just saved and then written to SD cards, which contain the firmware. So in Axiom Beta, you can actually switch firmware by just taking out the SD card, putting a new one in, or updating the SD card by flashing a new firmware on top of it and then plugging it back into the beta. The big problem is if we do new revisions of software, and the person maintaining the image doesn't realize and update that part of the software manually, it gets lost, and then you have a kind of dependencies that don't match anymore. So it's terrible, very complex and chaos, basically. So we always wanted or knew that the clean approach to do this would be through continuous integration.
Okay.
Which just means that you have a central software repository where all the source code is stored, like on GitHub.
Yeah.
And any changes to the software source code get pushed into GitHub. And the continuous integration is a kind of service on another server or infrastructure. And it notices, oh, there's been a change to the source code. I'll now collect all the source code from everywhere that I'm configured to, and will compile everything automatically and build an entire firmware image, which is kind of their file that contains the entire firmware, automatically. So the moment I make an improvement to any part of the software and push that to GitHub, 10 minutes, 15 minutes later, the new image is automatically provided that contains that new feature or that new software part.
So it makes this sanity check then.
It does some checks already. There are still a bit of checks more to be tested, but at least it collects everything and puts everything together. We still need to manually test and evaluate if the firmware is really good.
Yeah.
So in the developer's sense, this is called the nightly image because it gets provided every night, basically. And the two bright minds behind the Axiom Micro created this automatic continuous integration firmware. Not only the system that does the automatic integration, or the automatic building, but also the new firmware from scratch. So the new firmware is not currently providing any new or better features, but it's more cleaned up, more clearly structured. There's now a separation between the user of the Axiom and the administrator, kind of. Previously, when you logged in, you were root already, so you could easily also make changes that you probably wouldn't want actually to do. Now it's separated between someone operating the camera, making changes to sensor parameters, for example, and someone actually wanting to change the underlying firmware and the structure. And you can have more easy access to the scripts, to the parameter changes, to all the software that's on the Axiom Beta firmware, because not everything is in the root directory, which was a bit of a mess before, but the path value now points to all the binaries spread out in a more clear structure in the firmware. So the next steps are obviously to also add new features and make everything better in every aspect, but it's already a much cleaner and better approach, and the current firmware is pretty much identical to the feature set and the operation of the old firmware now. That took a bit of time, but now it's almost or entirely already capable of doing what was there before. Cool. Excellent. And previously, you could change parameters through a variety of scripts. Like there was a script to change the gamma curve. There was a software to read images, still images, that could also change the exposure time. So that was the easiest way to change exposure time through a software that would actually take still images. So it's all a bit glued together, all very diverse range of tools, which was a bit confusing, or is still confusing. And the next step, which is currently in development, is a central control daemon, which is like the central API for changing everything camera related, changing exposure time, adapting white balance, but also reading out sensor temperatures or temperatures from different areas of the camera, reading voltages, power consumption. It all goes through the central control daemon. Anything that's kind of what the operator wants to do, set, get, is the control daemon's business. That's also currently in development, and there are different modules for communication. Like you can control the control daemon from the command line. So there's a command line interface. There's a WebSocket interface. So for future graphical user interfaces communicating with the camera over web server, basically. There's a module, so you can also set parameters through that path, and it's easy to adapt for additional communication protocols like the XM Remote in the future. Will also communicate with the remote daemon, and then it will be a serial protocol interface, most likely, that plugs in the XM Remote to the control daemon again.
All right.